In the previous video, we looked at specific enthalpy for a two-phase mixture, and we had a formula like this. And in today's video, we shall look at the specific entropy formula for a two-phase mixture. What is entropy? In a video later on, we shall explore what's entropy and why does it matter in thermodynamics and physics at large. Where I clear a small insight into it. Entropy is a physics word for disorder. So what does it mean in physics? It means that if you cannot, energy will always spread out. Why is that so? If you ever boiled water and you put it in a cup, and when water boils at 100 degrees Celsius, and you press it on the table, naturally the temperature of that boiled water will have to come to a temperature that will run with the surrounding, the room temperature. And how does that happen? The cup containing that water will lose its heat, its excess heat to the surrounding until the temperature of the surrounding equals that of the cup to bring about equilibrium. And that sense of energy spreading from what you've artificially created to creating another artificial equilibrium is what we call entropy. And why did they use it for? Why did that Arya alone say it's chaos and it's disorder? If you cannot, there's this saying again in entropy and in thermodynamics, they say that without energy, it's only weeds that grow. Without work, it's only weeds that grow. So later on, we'll make a video about entropy, and we shall go deep into it and understand it. But for now, let's do a specific entropy formula for a two-phase mixture. Two-phase mixture means from the vapor dome graph, the liquid that's within the liquid and vapor phase. So entropy is represented by a capital S, which is equal to SF plus Sg. This is entropy of the liquid phase plus entropy of the vapor phase. Specific entropy is given by this, and once you take the entropy for the liquid phase and the gas phase, the vapor phase, you get something like this, and you substitute, and you get that. And we get this formula by substituting for mass of the liquid phase. And how is that done? If you've been following the previous video, you know that we get this by introducing the total mass, and total mass is equal to mass of the vapor phase plus mass of the liquid phase. And once you do the substitution, you will get something like this. And the same here, we introduce this as a substitution for mass of the vapor phase by introducing what we call the quality concept. The quality concept X is equal to the ratio of the mass of the vapor phase over total mass of the system. And after doing that, you will factorize out the total mass because it's common and it's multiplication, and you bring it out. Once you bring it out, you are going to divide through by that mass, so you get S over M is equal to this. And we know that from here, if you substitute this for here, you're going to have specific entropy, which is given by 1 minus quality concept into specific entropy of the liquid phase plus specific entropy for the vapor phase multiplied by the quality concept. And this is the specific entropy for a two-phase mixture. in the next video, we're going to look at the quality formula in terms of specific volume. The quality formula is, X, the quality concept. And now we shall look at how it's expressed in terms of specific volume. And thanks for watching.